Hello and welcome everyone to our Runtime Rumble today with Edera. Let me introduce myself first. As you can see there, hopefully, my name is Denham-Parry. I'm a staff solutions engineer here at Edera. So whilst we're waiting for everyone to join, I'm just going to do a little update as to what's been happening with Edera recently and where you'll find us next. So today's our Runtime Rumble, and it's part of our What the Frog series, and we're looking forward to being able to share it with you today about confidential compute. But before we do so, last week at Edera, we had a team offsite in the beautiful city of Denver where we all got together. And yeah, it was beautiful to see so many teammates in real life. And yeah, we've got some plans and we're so excited to share them with you over the coming weeks. And where will you find us over the next coming weeks? Well, first of all, you'll find Marina and myself up in another beautiful city, a bit closer to home for me. It's Edinburgh, where Marina will be giving a talk at KCD UK up in Edinburgh, Scotland. And I'm one of the organizers. So if you are around those parts of the world and you haven't already got your ticket, there'll probably be some links somewhere to find them. You can find it if you found us on the internet, you can find that on the internet. But please come up and say hi if you're there. Otherwise, if you're not in Edinburgh, then next month you can find us in the city of Atlanta. I should continue to say the beautiful city of Atlanta, following the previous cities that I've mentioned. And you will find us there for Cloud Native Rejects. And we're going to be there all week, right to the end of KubeCon North America. A host of the Edera Axes will be presenting talks throughout that week. And most importantly, if you're attending, well, our talks are of utmost importance. But again, that in real life moment, you can find us at a night in the aquarium. So we are hosting a party on Wednesday, the 12th of November. We will probably be sharing links right now, or if not right now, then you'll find them again somewhere else on the internet. I suggest Edera.dev. Follow us there on LinkedIn and on Blue Sky. That'd be great to see you there. Fun fact, I once sang karaoke to a whale at that aquarium, so who knows what it might happen again. But yes, so let's almost go into this. And I just want to make some things clear about this webinar today. You might not know what confidential compute is. You might know what the word confidential means and the word compute and jump to assumptions, which you're more than welcome to do. But if you're like me, you want to go in a bit deeper into it. And I'm so lucky to be joined by Marina today, who's been doing as such, and she's going to share her findings with me. So if you're starting with what the fudge is confidential compute, welcome. If you know a bit more about it, then please hang around. Please share your thoughts, resources that you found useful in the chat for others to use as well. And hopefully we get to the point where we understand that the number one rule of confidential compute is no one knows, well, no one talks about confidential compute processes, but hopefully we'll learn more about that as we go through this. Now, hopefully there is a poll here today, and on that poll, what we're asking you is, what's your biggest concern? Is it performance or security? We've lived in an age, I've seen the poll pop up now. We've lived in an age where you could either have performance at the cost of security, or you have security at the cost of performance. Now, at Edera, we think you should be able to have your cake and eat it and have both. But today, let's find out what's more important to you, performance or security. So whilst I've been chatting away, you've probably seen that there's someone sat next to me on this virtual fireplace that we're at. So Marina, would you mind unmuting and sharing a bit about yourself?
Sure. Yeah, thanks. I'm Marina. I'm a research scientist here at Edera and the head of Edera Research. So I do look into all kinds of cool technologies in the cloud native space and kind of how they relate to the work we do at Edera, which is a lot of fun. Yeah, that's who I am.
And you were in Denver last week, and we will see each other on Monday as well. So
Yes.
super excited, but we're here together now. So well, let's get into confidential compute then, and let's start to understand where we're at with it. So I use cloud services, I'm proud to say. Coming from my background with running Kubernetes and containers and so forth, I've been using cloud services for a while. And I know it's best practice to encrypt my data. So if I'm sending you something, Marina, I'm going to encrypt it so that no one can read it. And that secures it in transit. But what happens when it's actually being processed?
Yeah, so most of the time today, like when you encrypt your data in transit, like you said, and then encrypting at rest has been long been a best practice that most folks do, right? But when the data is actually being processed, when it's in memory on your CPU, on your computer, it's not encrypted, which means that other processes on your computer can maybe snoop in and see what's going on, and like even read your data and do all kinds of other stuff during that moment while it's being processed, while it's unencrypted.
So that's interesting because, again, I'm a consumer of these services of hosting my applications. And forgive me for feeling like this, but if I'm paying someone to host this, isn't that already a solved problem? Isn't this someone else's problem to solve?
So unfortunately, it's usually not, especially when you're using, other people's compute, right? When you're just running a process on your own machine, you kind of know what else is happening on the machine. Obviously, I think bad things can happen, but most of the time you can kind of control what's going on there. But if you're sending your data to the cloud, to get access to more compute power and all the other great benefits of the cloud, you have less control about other processes running on the machine. And when you have things in, say, containers, they still have this underlying shared host operating system that all your different containers are operating on, which means that they have shared memory and shared processing. Um, it's not like by default you can necessarily read everything if you have like security measures in place, but it's all sharing that same like space. It's a little bit like overhearing people at a conference or something, right? Like you're all at the same conference, you can probably hear other conversations happening in that space.
Yeah, most people are having their own conversations when I'm giving a talk at a conference, but that's something for me to deal with. But yeah, and I totally, because the cloud for me it's essentially like a hotel. It's that when I'm running a VM, it's a room essentially within that hotel, and I've got it for that period of time. I go into this room and I'm expecting it to be clean and fresh and like almost like no one else has been in there. But the truth is, someone's already been there, and someone will be there after me. And usually, when you have those adjoining doors as well, that always terrify me because what happens if someone comes through that door in the middle of the night? And so to what you're saying is similar because I guess back to our poll about security and performance, the cloud service providers, they're focused at getting as many people into this compute. Well, when I say people, company, whatever it may be, to utilize as much of that compute as possible. Um, so uh, what what does confidential computing do from a high level anyway to address this?
Yeah, so at the most basic level, what confidential computing is it's like a hardware-based technology that allows for encryption and use, right? So it solves this problem we talked about. So now you can not only have your data encrypted in transit, encrypted at rest, but it's actually encrypted in the memory while it's being processed as well. And okay.
Yeah. So, and you mentioned encrypted during that process. Now, to me, back to security performance, is that at a cost of performance if I've got this encryption?
So that's part of why it's a hardware-based technology, right? There are technologies that do encryption without hardware, something like homomorphic encryption, but that has a lot of like limitations in what you can actually do on the data and other things. Very cool technology. But what confidential computing does instead is it uses this what's called a trusted execution environment, or TEE, which is a piece of hardware that actually you do all that encrypted communication on this separate chip. So right, instead of using the same shared CPU, you're using this trusted execution environment. And because it's in hardware, there is still, in general, a slight performance penalty, but it can be a little bit less because based on the design of that chip.
Yeah. And but can I trust the hardware? It's because if I go to the store now and I purchase a piece of hardware, is that equivalent to a T? Is that it can does that help?
That's a tricky question. And I think this kind of comes down to like the big question of confidential computing, because what you're doing is you're kind of replacing trust in, your CPU, your underlying operating system, your cloud provider with trust in this hardware trusted execution environment. And while they are designed for security, there have been vulnerabilities that have been discovered in the trusted execution environment, generally in that memory encryption piece, which is the key security component, which means that and I think this is partly just because this isn't involving new technology, and unlike software, hardware patches, right, are take more time. And so I think as the technology evolves, maybe that will improve. But yeah, so that's exactly the trade-off you're making, right? You're replacing the trust with the trust in this piece of hardware.
And so we're talking about trust now. And in a past life, which was like last year, I did lots with Salsa. And with Salsa, I talked a lot about attestations and provenance. Is there a comparable between the attestation and provenance of software to that with hardware in this instance?
There is, yeah. And so there's something in confidential computing that's called remote attestation. And so this is the idea that before you send your sensitive data to a remote machine that is using confidential computing, you want to make sure that you actually, are sending it there and not to just some other random machine on the internet. And so what this does is it lets you like attest to the state of that hardware environment and even like the state of the application that you think should be running in it. And then you can do like establish a secure channel to that particular device. And you do all that before you even send the data to make sure that the whole thing is, secure end to end.
Awesome. And just from my memory of those days back to, so I used to jump on calls to discuss about Salsa and attestations and provenance. It was a case of understanding what they mean, because again, I didn't know what it meant at the time, and I've learned what it, and there's this analogy of an attestation is a bit like having a seal on a bottle of your drink. It's a way for you to be able to trust that content hasn't been impacted since it's left the factory. And provenance is being able to identify the factory where it was built with the batch number that it was, the ingredients within it. So ultimately, for movie Wolverine's Origins should have actually been called Wolverine Provenance, in my opinion, but that's just another thing. That's another hill for me to die on another day. And so yes, with attestations and provenance, that's allowing us to build up this trust, because all of a sudden, so far in this call, we've learned that we can't necessarily trust where we're running things. And is that a problem? Well, potentially. Well, actually, this is just for my website that I've just created for people to send song requests for my DJ set tomorrow. So I don't think that actually means, I don't think I need confidential compute for that whatsoever. There's no personal identifiable information in there. So what industries are looking towards confidential compute today?
Yeah, I think you see this most in areas that have more sensitive data or are more, highly regulated, generally also because of more sensitive data, right? So things like healthcare, things like finance, those kind of business areas are looking into this a lot. Some of the AI, especially AI training space, is looking into this a bit as well, because those model weights for these big large language models are like that's the keys to the kingdom, right? That's their main thing that's the magic behind the LLMs. And so, keeping that encrypted is super interesting and like important. So yeah, so those are the main areas you see this today, because it is, it does require this specialized piece of hardware, which adds, some cost and some additional overhead. This really isn't for like every single person running every application. Maybe we'll get there someday, but right now this is really for folks who need that extra layer of protection.
That's interesting, because right now I don't need it for my DJing application. But ultimately, I think it's my data is being used by those industries that you've mentioned. So even though this doesn't necessarily impact me right away, there's parts of me go floating around. It doesn't sound so great, but there's a cause of concern for myself as a consumer, because naturally I do have a bank account. There's medical records for me, and I have been using AI quite a bit. So I guess there is concern there for me. The other interesting, I was at a conference a couple of weeks ago, MCP Dev in London, and I met someone who worked with Hollywood studios. And I was mentioning that I'm going to be on a confidential compute webinar in a couple of weeks. And they said, that's totally fascinating for us. That's the problems we're trying to solve. And what they said to me was that they were part of a big budget movie series that we're all probably aware of. And during the studio, they had to have animators go in. And the animators would, because it's still a fairly manual process, and the concern for them was that there was a risk that if someone took a screenshot or just a photo on their phone of the work that they were doing, it would completely compromise the budget that they were looking to attain in the box office, because it would be spoilers, essentially. So, and I find it interesting because it's, as you mentioned, AI there. When we're building these LLMs, it was recently, I saw a figure, who knows, it's off the internet, but it was 4.5 million to build these models. So to your point is that if these are being impacted at that time, there's a significant cost that can be attributed to these businesses. So, and well, there we go. That's more of a statement piece from me. So we started with software, then we went to hardware. Let's go back to software for a bit. So how does confidential compute differ from traditional cloud security measures as well?
So I mean, there's a lot of different cloud security measures out there. So I think this just kind of fits into the suite, right? So you have I think there's a lot of work that happens like above the operating system level in cloud security today. Things like monitoring what's happening, um, providing access to different resources, all that kind of stuff. And if you think about like a hardware stack, right? I think a lot of traditional cloud security lives kind of in user space, right, on your system. And then all the stuff below that, your operating system, your hypervisor, the hardware itself, people tend to think a little bit less about that because part of the beauty of the cloud, right, is that it's a little bit agnostic to the exact hardware, et cetera, that you're running on, because we have these APIs that can communicate all in user space. And so I think there's a lot more work that happens at that layer of the stack. And confidential computing is one of the technologies that kind of turns this around and says, what if we focus at the very bottom of the stack? What if we look at the hardware itself and how we can provide you with security, isolation, encryption from the hardware, right? And then you put those other layers of the stack on top of that.
So if I were to use, or look to use confidential compute today, and say that I've got a Kubernetes cluster, I'm going to start with a Kubernetes cluster. That's going to be, I've got some YAML. If I'm someone who utilizes YAML on a daily basis, how would I be configuring? Would I need to rebuild my application? Would I need to specify stuff within YAML, or would it be someone else who's managing that for me?
Yeah. And so I guess the first thing I have to say is that when we talk about confidential computing, everything I say is going to be a generalization because what we're actually talking about is a couple of different specific hardware chip designs that enable different pieces of technology. And as of today, there's not really any universal APIs that can talk to all of these different chips. And so all of it is very specific to the actual hardware. That's part of the challenge of working right at the bottom of the stack there. And so, what I will say though is that what's most common is if you're trying to get like an existing cloud application running in confidential computing, what you do is you put that cloud application into a VM, a virtual machine, and then you run that virtual machine inside the trusted execution environment. And this has to be in one of the trusted execution environments that has like slightly more memory, like space on the device. Some of them are too small to run like a whole VM inside the chip. The AMD SEV, I think, is one of the more common for this type of model of running a whole VM on the chip. So if you have your application today, you would have to, the application itself would probably stay the same, but you'd have to do some work to make sure that it was sitting inside a virtual machine of some kind, and then that could run on the chip. There's a couple of CNCF projects, I think, that are working in this space, right? Trying to make that compatible with your existing cloud application.
Because that feels similar to what we do at Edera. And I'd argue that we do it a bit we make it simpler for the end user within Edera in that, so you mentioned about putting a VM inside this trusted execution environment over T. And also I love T because I'm British. So it's like finally an acronym that I can jump on board with. But so we're putting a virtual machine inside that T so that we can trust that virtual machine essentially for our workload. But the thing, with my experience of VMs and so forth, that feels quite costly, and it also feels kind of against principles of cloud or Kubernetes, whereas a case of trying to get the most out of our compute and be as efficient and scaling as possible. So at Edera, what we have is that we've got Edera zones, and Edera zones are what provide you that security boundary essentially. So you can run, whether it be a container, whether it be a pod or a namespace within this zone, and then only what's inside that zone you're able to see. You're not able to see outside that zone. And also outside of that zone, it's not able to see it in either to give you that isolation piece. Would that be comparable to what you just said there, Marina?
Yeah, I think it would be. And another thing I like to think about here is what in security you call the trusted computing base of your application. And I think this relates to what you were just saying, because basically when getting applications to run in this trusted execution environment, there's kind of been two schools of thought with variation in between. One of which is kind of what we were talking about earlier, where you want your existing application with as little work as possible to be able to run in the trusted execution environment to really just enable adoption and quick, speedy adoption and all of that. And then there's another kind of more like principles driven, I guess, theory, which is that you should really design your application to be as small as possible. So you're running like the smallest amount of stuff in this trusted execution environment that you need. This generally requires reworking applications and like kind of said, like, pulling apart your application, right? To say this is the part that's more sensitive. We're going to run that in the trusted execution environment. All the rest of this application is not sensitive. You can run it wherever. So this comes back, that has much smaller, what's called a trusted computing base, because there's less code in that trusted piece of hardware versus the kind of VM approach I was talking about earlier. You don't have to change your application; it's easier to do. But now you have a whole Linux kernel inside your trusted execution environment, right? So that you have a lot more trusted code that you're running inside of it. And so what Edera does is, I think, kind of a middle ground between those two things, where because Edera runs on kind of on a Zen-based hypervisor, so it's sort of like a microkernel hypervisor. There's less code involved, like there's less trusted code that you need in order to run an Edera zone. And so that does help with this problem of the trusted computing base a little bit. I think I'm not sure I answered your question, but
No, I as ever, Marina, you've answered it and more for myself. So thank you as ever for that. Yeah. So I can see that layer now, and so we're down towards the hardware, and so we've gone from the top, we got to that hypervisor, and so the hardware itself. Are there any names familiar to me from the industry? Like who's a part of this? Where is this hardware coming from?
So it's the kind of the big names, AMD, Intel, and there's an ARM one as well, and I'm sure there's others I'm forgetting off the top of my head. So yeah, there's kind of like a handful, and there's different generations of them as they improve the design of the hardware itself. So I mean, like, yeah, Intel SGX, AMD Sev, and ARM, like TrustZone, are probably the three big players in the space, and I think all of those companies are kind of iterating and coming up with more designs.
And because we've now got this far deep, and to avoid my own confusion, so do I need to host confidential compute myself, or is this someone else?
You can do it either way. I think that you see a lot more of the value with these cloud systems, right? Especially because part of the beauty of this, like having the encrypted memory, is that in compute environments that you don't control, right, you can still establish trust in this one little piece of hardware in that whole ecosystem. So while you can totally run it yourself, and that's a great way to learn about it, and if you're running your own data center, right, obviously that's a great way to go. But if you're not, you're probably going to be accessing other people's hardware, just so you don't have to pay for a whole chip yourself. Yeah.
Yeah. And because I've seen that within the industry, and the basis being is that they want the benefits of the cloud, which is scalability, essentially. It's that they can't manage the demand that they're getting requested for compute at a moment in time. But their risk model is not comparable to that of the cloud, because from what you've mentioned so far, I remember speaking to people to say, well, you can just do this. But to the points that you've mentioned, it's like, what happens if so if I talk about a threat actor, so what that means is, like, if there's someone who's got access to the compute in this instance, say that there's someone who's managing that data center for you, if they could SSH onto a node, and if they had malicious intent, could they go into these processes? And so for that, they couldn't even trust someone else to do it for them, so they make their own data centers. Whereas it sounds like confidential compute is allowing to build up that trust on the attestations and provenance from hardware all the way up the stack to the top, so that they can potentially use that scalability of the cloud. Would that be right to say?
Yeah, I think that's a good way of putting it, right? So you can basically gain that extra trust in the cloud through the use of this trusted execution environment, but you can still get a lot of those scalability benefits. Now, these TEs, they do have certain, limitations on the number of workloads that can run on them at one time, or like the number of encrypted workloads and the amount of space you have for each workload, which I think I hinted at earlier. And so this is definitely challenges for doing like a full cloud scale. But especially if the confidential computing is one piece of your cloud story, right? Like if you need some applications with really sensitive data to be on these trusted execution environments, and others can be elsewhere in the cloud, right? They can all kind of fit together in that way.
Great. That's great. So recently as well, so we've mentioned the cloud, but there's someone else, Apple. So I've recently seen them, there's something about protection that they've released. Is that something to do with confidential compute, or is that something else entirely?
That's something different. So they have what's called private cloud compute. And it can be a little bit confusing because they do a really cool kind of hardware supply chain attestation process for the devices that perform private cloud compute. But what that does really is they're trying to basically take the privacy model of their on-device operation and put that into the cloud. Because these large language models are too big to fit on a phone, so they're trying to get kind of a similar privacy guarantee while running some queries in the cloud. And so what they're able to do, because they control kind of the whole hardware software supply chain, is create these kind of secure pieces of hardware with no encrypted memory, but otherwise kind of very secure piece of hardware, things like secure boot, all that other great Apple security stuff that they've been known for. And they do a lot of clever things to make sure that an attacker can't direct specific queries to a specific compromised device, and that it's like encrypted for the specific device. So they have really great use of encryption in transit, encryption at rest, but they're not actually doing that encryption in use. In some ways because they don't need to based on the other pieces of the system that they control.
So, and you mentioned other pieces there. So am I right in saying that confidential compute is kind of complex? Is there lots of different layers to that?
A little bit. I mean, it's really just like at the fundamental level, I think it's pretty straightforward. It's the use of this specialized piece of hardware, which is incredibly, clever designed, etc. But like as a user, all you need to know is that, it's this piece of hardware that does the encryption and you send your stuff there and it is encrypted. I think it's like any piece of technology, right? It's all built on other technology. And so it's very complex, but you can if you just look at like the abstractions, it can look pretty simple.
And so of these abstractions, are we seeing that they're like open standards being created? Because you've mentioned that like some people are doing things slightly different at the moment. Is there governance coming in? Is there something else trying to make it so that it's consistent in different implementations?
So there are some industry groups. The Confidential Computing Consortium, I think, comes to mind. It's a group under the Linux Foundation that's trying to bring folks together to do exactly that, to have some open governance, some open standards around confidential computing. Because so far, I think a lot of the development has been driven by these hardware manufacturers. And again, they've done some very clever designs, and it's kind of cool to see the different designs competing to see kind of what works for people. But it means that, if you create an application that runs on one trusted execution environment, it probably won't run on a different one, maybe even a different one from the same company. And so I think in the long term, these kinds of open standards will help drive adoption because it'll just be a lot easier to to run your applications kind of like we used to in the cloud today, right? Where you don't even think about the hardware. So
Yeah. Oh. And so I briefly mentioned this before about performance. So with confidential compute, is there an overhead that people should expect when transitioning from what they're currently doing today to potentially a confidential compute structure?
I'm gonna give that annoying answer. It depends. um, so because the different pieces of hardware are all very different than each other, I think it's hard for me to give a single answer. I think that if I had to give a single answer, I would say that it would be a very slight performance penalty. But it depends on how much you rewrite your application and how much optimization you're able to do and etc. So.
And what do you see as the current limitations and constraints for someone to adopt confidential compute today?
A couple obvious ones are the cost, right? So you do need access to these chips, and there's only so many workloads you could run per trusted execution environment, which just kind of inherently adds some cost, right? You have extra hardware, extra things that you need. The compatibility, I think I talked earlier about that kind of trade-off between compatibility, compatibility and trusted computing base. And I think the reason a lot of people are moving in that compatibility direction is to kind of ease this adoption story. That's definitely still a consideration. And the engineering time it takes if you have to do any of that transition. And then finally, I think your threat model and whether this is what makes sense for your organization. I think, yeah, it's a great piece of technology, but I think that, again, you're not eliminating trust, right? You're moving trust to this piece of hardware. And so it's just a risk decision about whether that's the thing that makes the most sense.
And so today, could I, to go back to Kubernetes for a moment as well, could I have some nodes which would be confidential compute so I could run some workloads there, or would it be outside of my stack entirely?
That I think is the vision that a lot of these groups that are trying to make that compatibility happen are going for, right? So you have, some nodes with your more confidential stuff, and those run on these trusted execution environments. Other nodes that maybe don't have sensitive data can run elsewhere. I think that's kind of where I see the long term, where there's going long term in kind of that cloud compatibility space.
Now, I don't know if you mentioned this in the intro, but I'm allowed to say this. I think you're kind of a big deal in cloud native security. Like if it's one of those people that I've looked towards if something was going wrong for not for the reasons that people look at me when things are going wrong, but more that I look to you for advice. Because you're with tag security, and so I don't know if you've like heard of these things called like CVEs and so forth. And yeah,
The
it's
names didn't come up.
yeah. So like CVEs is just when there's like bugs in software that cause malicious things to happen, things that you don't want to happen, things that you're not expecting to happen, that can cause really bad days and different levels of bad days. Is confidential compute susceptible to these things as well, or
Unfortunately, yes. Unfortunately, like all software or hardware, it's written by people. All software have bugs. Firmware is still software. So unfortunately, yes. There's been a couple of ones recently, actually, in the confidential computing space. And of course, like when you're attacking confidential computing, as an attacker, right, the goal is to eliminate that memory encryption, that like encryption in use piece of the model, right? Because that's like the key extra benefit that you get. And there have been a couple recently. I think the one I read most recently was called battering RAM. And this one requires physical access to the device. But again, if you're running your workloads in somebody else's cloud, like it's hard to say whether other people will get physical access. So this is one of the rare cases where physical access is actually like, a possible concern. But with physical access, what they were able to do is put basically a device between the memory and the processing. So like within the chip, there's space where the data is visible basically. And so by getting physical access, they were able to put this little, it was a cheap device that they were able to use. It was like a $50 device that could like read the traffic on the chip. So super clever kind of hardware attack. Different other ones too, again, mostly targeting the memory. There was a clever one sometime in the past year that actually attacked the encryption algorithm itself, right? Their use of a block, what's it called? Block encryption. Like anyone see like the Linux Penguin attack? I don't know if we have a picture of that, but someone could post one in the chat of like where, if you encrypt every block of it, but you're using the same key for every block, you can still kind of see the picture. It was a very similar attack, but a little bit new and different on the encryption that one of these devices was using. So that was very clever. Sorry, I hate to sound like the attacks are good, but they are very smart. The folks who come up with them. So
well, and thank you to Jed for sharing the
yeah,
image within the chat.
Make sure there.
And that's the interesting thing is that attackers are like they are smart, and also there's some attacks that are fairly simple. Some attacks that I've seen recently are due to, for whatever reason, just leaving susceptible things online. I remember in the UK, for instance, I think it was about 10 years ago now, there was one attack on a multinational company based in the UK, and they called it out as a nation state attack. And it was actually, I believe it was a 14-year-old from Belfast who watched a YouTube video on hacking. But I think the importance as ever is to make it as difficult as possible for attackers to be able to do these things. And so in this instance, yes, there are levels to the complexity of this attack. And especially as you've mentioned, it's a case of maybe you mitigate that by your own data center and vetting your own, but back to that scalability and back to what you were mentioning about the threat model, because if this is within someone's threat model, then then that's going to cause different decisions to someone else. So I guess part of this as well leads to understanding what your requirements are as much as anything else to decide what is this risk, where do I need to invest this time and effort. But yeah, so today coming into this, I've been looking into some of these disclosures that have happened around confidential compute, and they are really, really interesting. And we will be sharing all this within a blog as well, following this with all links to the resources that we've discussed. So are there any side channel attacks as well that threatening confidential computing in other ways as well? And are there any mitigations to these that exist currently?
Yeah, side channel attacks are one of those classic kind of hard to mitigate types of attacks, especially when you have an attacker with physical access to the device. I think that battering ram attack I mentioned earlier could be considered sort of a side channel. I mean, they did have to put a new device onto the chip, but it's basically a side channel, right? That they were able to observe that behavior. I'm not sure the exact classification, but I think it's related. And yeah, and so I think stuff like that too, right? Because if you're able to have physical device, there may be side effects that you're able to see from what's going on inside the chip. So unfortunately, those are, they're just very challenging to totally prevent. There's things you can do in the hardware design to kind of make it harder. But yeah, that's just a big challenge.
I think the irony right here is that this is going to be recorded. So you can actually go back in time and you can see me when I'm thinking about asking that question, realizing actually we kind of already answered that just a moment ago. So maybe if we could put this into confidential compute, so whenever this is processed, like no one else can see this, that'd be just that part, that'd be fantastic. So let's talk about the future then. What do you see the future is with confidential compute?
Yeah, I see a couple of different things. I think that the hardware is going to keep getting better. I think some of these CVEs that we've seen in the space will kind of influence the next generation of chip design. And so I'm kind of excited to see what things people come up with for that. And I think that the other piece that I really am optimistic about is this idea of open standards and open APIs, basically, so that you can write things that are compatible with different things, which allows for better comparison between the devices and better usability, right? So if you're, especially when you're thinking about the cloud, right, like it's nice that you're able to swap stuff out. If you run out of space in one thing, you can use a different type of chip, that kind of thing. And I think that that will be really enabled by more open standards in this space.
And do you see Edera fitting in this future at all with confidential compute? Do you see Edera fitting in nicely?
I do. I think there's two different ways that I kind of see Edera fitting in with confidential computing. The first kind of most obvious one is that because Edera runs things in zones, which are basically similar to VMs, you could run an Edera zone inside on a trusted execution environment, right? And so, and this enables you to get both the isolation and in-memory encryption from the trusted execution environment, but also because of the way the Edera is designed, you also get some protection from a malicious workload in that trusted execution environment. Because one thing I haven't mentioned is that while you're protected a lot from vulnerabilities in the hypervisor, the operating system, etc., if you have an application that's still insecure, this just kind of puts it in a box, right? It doesn't actually prevent that from happening. And one thing that Edera can give you is better visibility into that application that's running on the chip, and also prevent side effects from that application from escaping into your hypervisor or other pieces of your system. Oh, and the other way, sorry, I see Edera fitting in with confidential computing. I think it's kind of as a middle ground for folks who maybe aren't ready to make the total leap to confidential computing, but still want some additional isolation for their cloud workloads. I think Edera provides that, with your applications today without the hardware costs. And this can be like a really powerful middle ground, I think, and especially with features like attestation of your Edera zone and other things like that. You can get some kind of similar features, but it's all kind of software based with Edera.
Yeah, definitely. So with Edera, we install on your VM, on your bare metal, or well, essentially you might see as your node if it's in Kubernetes. And then if it was Kubernetes, you change it to runtime class name Edera. and then you've got that benefit. You don't have to rebuild that container. You don't have to change all your nodes, even though you think you should, to be running Edera. It can be a part of your cluster, and then you get some of the benefits that we've been mentioning about that blast radius and without that hit of performance as well. So yeah, but there'll be, obviously, you know where to find out more information about that, and always feel free to reach out to anyone with Ivy on them. Right, I think it's time for some Q&A, if you're good with that, Marina.
Yes, yeah.
Splendid. So first question is, what are the performance implications of approaches like homomorphic encryption?
Yeah, so homomorphic encryption, I think I said the word briefly earlier. What this is it's an encryption technology that lets you operate on encrypted data. So this is kind of cool. And there's unfortunately huge performance penalties, which is the answer to this question here. But what it lets you do is you take two pieces of data that are encrypted in a specific way, and then you can actually perform operations on that data. And then once you decrypt it, it'll like have performed the operation. So like you could say add two values without ever looking at the two values, and then you send it back to the person added. And this is super powerful, but yeah, it can be very slow because you're operating on the encrypted data. And you basically have to do more complicated operations in order to complete simple operations on the unencrypted text. So yeah, super cool technology, but definitely has higher performance penalties than something like confidential computing.
So I hope that's answered your question, whoever you are outside of this room. And please follow up with another question if you do so. And if you are watching in the future, hello from the past, please, if you do have questions, either drop them in the comment and wherever you're watching this, or LinkedIn, Blue Sky, or just find us at edera.dev. Next question is, I hear about confidential computing a lot more in relation to securing AI workloads, models, etc. Why is that more important, or is it?
Oh, it's so hard to say more important in security, right? I think with my security hat on, I think securing everything is important. But I think one of the reasons you're hearing about it a lot is the money behind it. It's just, it's like a small bit of data that has a lot of money behind getting it trained. And so I think that's why there's a lot of interest from the folks in the AI industry in confidential computing. And again, yeah, it's a leading driver of something I haven't mentioned yet, which is kind of GPU-based confidential computing as well, right? So far, most of the stuff we've talked about is in the CPU space, but obviously GPUs also have sensitive data, and so there's a whole nother kind of set of devices that are aiming to solve this same problem, but for GPUs. And that's especially interesting for the AI space, right? Because it's very GPU heavy.
Yeah, and GPUs just make the problems a lot faster, if anything, from
Yeah,
what I'm
exactly.
learning. And it's again, we'll look to follow up with this link, but I think it was last week Anthropic mentioned that about LLM poisoning as well. So, and how disruptive that is still today. So that means just a couple of lines can completely distort the LLM. And so it comes back to this position of trust, in that if anyone can impact that state, then we're going back to, well, maybe it's not so much about personal identifiable information, but it's that cost of millions to be able to build this model that could just be wasted at that moment.
Exactly,
So
yeah. And it doesn't, there's all these studies, it doesn't take that much poison data to affect the whole model, to make the whole model either less accurate or in specific circumstances give that information. And so, yeah, this is a huge cost. If you spend billions of dollars training a model and then there was just like 1% of your data turned out to be poisoned, that's a huge problem. That's a lot of money wasted.
yeah, well, hopefully it's on credit cards and they're getting air miles, because but anyway, that's not necessarily the solution that we should have to everything. But okay, I've got one more question here, and if there's any other questions, please add them. But can data sovereignty regulation accelerate technologies like confidential computing?
I think the short answer is probably. I think what these regulations can do is like accelerate adoption. I think the actual creation of the technologies is a little bit separate, right? There's a whole process for how they evolve over time, and especially with security technologies where it takes a lot of iteration where people are trying to attack them and you learn how to make them better. But I do think that this can help accelerate adoption. I think we've seen this, with clouds moving to different countries and stuff like that as well. So.
Yeah, and data sovereignty does feel like this is part of trying to solve this problem is by having our data set. And again, recently, in the UK, for instance, we've seen that Nscale have just raised a Series B at 1 billion, and is the largest ever raised within Europe. And so now we're seeing this huge focus. And again, maybe it's just AI accelerating literally everything, including that now as well. Right, we've got a couple more questions coming in, and we're getting stuck on time, so I will ask: are there efforts to democratize something like confidential computing? The upfront hardware and complexity cost seems to limit this to high security workloads.
So yeah, I guess the question here is like, is there a way to make it easier for more folks to access it? That's kind of what I'm understanding. Hopefully, whoever's asking that, that's what they mean. And I think that I haven't seen something there. That doesn't mean it doesn't exist. I think it's a great idea because I do think, especially, in the research space, right, the more people who can access them, the faster we can learn how to do all of this better. And the more developers access them, right, the more technology we can write that works on them. So I think this is definitely going to be a super important piece of the technology maturing. But I think for now, there's so much churn in the space. And again, there's that lack of compatibility between different pieces of hardware that I feel like we kind of need those open APIs before we can talk about something broader about open access. So.
Thank you. Yeah, anonymous attendee. That person's got loads of questions today. So we've got one more, and again, please, we've probably got time for a couple more. Otherwise, we can finish a little bit early and get some time back after this. But what certifications or compliance frameworks most recognize confidential computing today? Do you see it as emerging?
I think I do see it as emerging. I can't think of any that like specifically require it today. There might be some in some of those regulated industries, things like, finance, healthcare, that are emerging. I do think this is probably going to be coming, right? Because as the technology matures, I think these standards, I think intentionally, right, they lag a little bit behind the tech because they want to make sure that the tech is able to be adopted before they require everybody to use it. But I do think that's probably the trajectory that we're on.
Perfect. Well, thank you again, Marina. Well, I'll say now, thank you so much for your time, Marina. It's always a pleasure. I'm just some of our chats that we had in Denver last week. Honestly, it's just, I'm super excited for Edinburgh when I get to see you there and ask you so many more questions. And I try not to ask the same question twice, but no doubt I do. But thank you today for your time. And again, if this is of interest to you, I'm pretty sure it is because you're still here. We'll be sharing, and I think we've already shared it in the chat, Marina's blog post series on confidential compute of what the frog is confidential compute. Oh my gosh. We've got one last question that's come in, and I can't let this person, it's Salman Iqbal. Also, good friend, good friend. What are the biggest misconceptions people have about confidential computing? And that's also a great question. Maybe I should have asked that, but thank you forever for having my back, Salman. But Marina,
Yeah.
what are the biggest misconceptions?
I think there's a couple here. I think that, like most security technologies, there's some folks who think it's kind of a silver bullet, right? That it'll solve all of your security problems. And while it does solve a security problem, right? It gets you this encrypted memory thing. You still have to trust all the code that's running on the trusted execution environment. And you still have to trust the hardware itself, right? So I think that it's really important to think about it as like moving your trust and kind of condensing it rather than just kind of you wave a wand and now your workloads are secure. So I think that's one big misconception I see here. And I think the other one is really that confidential computing is one thing. And I think, as we've talked about it today, and as, the more you read about it, the more you realize that it's a series of different pieces of hardware that do similar things. And so anytime you hear a generalization about confidential computing, I highly recommend looking into what that generalization means on each piece of hardware, especially if there's one that you're using, because it's just, it's very important to be specific when you're actually trying to implement this kind of thing.
I hope that answers your question, Salman. And so thank you, Salman, and also the anonymous attendee for all the questions today. Yes, and so I
Thank
think
you for hosting. Luis, you're doing a great job guiding my my thought process.
We'll have a high five.
Yeah.
There, that's
Virtual
it. Thank you. Yeah, virtual high five. So I believe we had a poll whilst we've been doing this. I don't know if the poll is being seen. It might be there, or there. Oh, there we do see the poll. Great. So what's your biggest concern, performance or security? So performance is low at 10% and security is rising high at 90%. But again, if you don't want to have to pick one of those in the poll and you want to have them both, then please don't reach up a phone because we're past that. Drop us a message, whether it's on LinkedIn, Blue Sky, lewis@edera.dev, or find us at edera.dev. At Edera, we don't believe that you have to choose between security and performance. We feel that you can have both, because essentially what we've learned today is that we do require this level of security, and that's what we're going to be getting now. So yeah, just closing. You'll find both Marina and myself at KCD UK in Edinburgh next week. There are a couple of tickets left over, so if you do want to come along, it's going to be great. Not just the talks, but the city. It's a beautiful city. And I've heard that they like whiskey. I thought whiskey came from America, but oh my gosh, I can't go to Scotland now after saying that. Like again, let's cut that. Let's cut that from a video. And if you can't make it up to Scotland, then please come find us in Atlanta. We will be there from the Saturday with Cloud Native Rejects, which is an amazing conference. Always the best way to start your KubeCon week, in my opinion. We might be having a little get-together as well on the Sunday, so please follow us for that. But other than that, you'll see us at KubeCon. You'll see us at the events. Marina, where are you going to be actually at KubeCon?
Yeah, I'll be at Rejects. I'll be at Maintainer Summit on Sunday. I'll be at Open Source Security Con on Monday, and then the main conference Tuesday through Thursday at the Edera booth and elsewhere.
What Marina's trying to say is you'll find her on the stage and you'll find me at the booth. So so thank you, Marina. And yes, and we've got the night at the aquarium as well at KubeCon, so please join us on the Wednesday night. It's a free event. Just sign up, get your ticket. You might be singing into a whale at the end of the night. Last time I sang Under the Sea because, you know, you only live life once, and if you can't sing Under the Sea to a whale, then I don't understand what else you can do. And finally, our next Runtime Rumble, we've already got it planned. Like, we're so organized, and thank you to Theo, who helps manage all this for us, to get us all organized. So our next one will be on the 20th of November, same time as now, or same channel that you're watching it on. And we'll be joined by Ian Smart, and we're going to talk about Kubernetes isolation, because there's isolation that Edera provides, but what about Kubernetes in general? Like, are there other concerns that we need to be looking at? And so I'm really looking forward to that. Ian is also a co-organizer of KCD UK, but honestly, when it comes to security, he's another secure person. So excited to see that. So thank you for your time today. Please feel free to reach out to us, like, share, whatever it is. I don't know, just click buttons. And otherwise, I look forward to seeing you next time at the Runtime Rumble. Cheers, everyone.
Thanks, Lewis.